Hey, how are you? Hope you're doing great today. We're going to talk about this problem just now. Says the distribution of the weights of containers of yogurt follows approximately a normal distribution. Based on a very large sample, it was found that 10% of the containers weighed less than 14.21 ounces and 20% of the containers weighed more than 17.68 ounces. What are the mean and the standard deviation of the distribution of the weights of containers of yogurt? There are five options. We have to select the correct option. So let's move a little bit up and draw the diagram. So it looks like this. Normal distribution. So the mean and the sigma are unknown. But we have been told that 10% containers weigh less than 14.2 ounce. So if this is 14.21 ounce, the probability that a container weighs less than 14.21 ounce is 10% or 0.10 is the area under the normal curve below 14.21. And 20% of the containers weighed more than. So more than is on the right tail. Area of the right tail is 20%. So this area is 0.20 and this area is 0.10 and this value is 17.168 because 20% weighed more than 17.68. That means the probability under the normal curve representing the weight of the containers area under the normal curve beyond 17.688 ounces is zero point 0.2 or 20%. So we need to find the mean and the standard deviation. So let me create a little bit more space. So I will convert the information into a Z curve, standard normal curve. Okay. So this is the Z curve. Z is equal to 0. This is the Z curve. Okay. Or standard normal curve. Standard normal curve. Normal curve. Remember, z is equal to given by x minus mu divided by sigma. Okay. So if we do not know the value of z below which area, so let's call this z1. Area here is 0.1. And we also don't know this value of z2, area above which is 0.2. But we can use a TI-84 calculator. So we are going to use our calculator TI-84. Specifically, we are going to use the formula called in norm in the calculator. So we will use, first press the second key on the top left corner of the calculator, then the verse key, which is in the third row, and then number 3, which is im norm. So im norm function we are going to use second verse 3. And first area we will type is im norm to get Z1. Area below the curve is 0.1. Mu is standard normal curve, 0. Sigma is 1. And we'll put the cursor on PEST and hit enter and enter twice. Whenever we are on PEST, we have to hit enter twice. Okay. So 0.2, sorry, it's 0.1, not 0.2, 0.1. And paste enter and enter. And that particular Z1 value comes out as minus 1.28. Okay. We will repeat the process for Z2, but for Z2, so if I create some space, for Z2 area under Z2 is 0.8. That is what we have to plug in the calculator to find Z2. Always the area on the left of Z2 or the left of the unknown Z. So let me draw a line over here. To find Z2. Again, second verse. And then number 3, im norm. Area now will be 0.8. You ask, no, why not 0.2? Because TI-84 is programmed to take the area below Z2, not area above Z2, which is 0.2. And same mu is 0, sigma is 1. And then we do paste and Z2 works out to 1.6. No, yes, 1.64. So let's make sure second verse 3. And then 0.8 and paste and enter, it's 0.8416. So let's take it as 0.84. Okay. So we got the two values of Z1 and Z2. Z1 is on the left of 0 is my negative. Z2 on the right of 0 is positive. Do not quit now. Please do not quit now. I'll give you some important tip at the end of this program. And I have solved all kinds of math problem in my channel. So please subscribe to my channel by hitting the red subscribe button. But please hang around. I'll give you some important hint on how to solve this problem. I will go over all the steps again. So first we found Z1 and Z2. Now we are going to utilize the definition of Z1 and Z2. So for that I need some space. So let me change the color of my pen. Let me use this color. Okay. So Z1 is equal to minus 1.28 is equal to X. X is already known. If you go up, so if I go up is X1 minus mu and sigma. So minus 1.28 is equal to, so let's move up a little bit and see what is the x1 value. The x1 value is 14.21. So 14.21 minus mu divided by sigma. Or if we multiply by sigma on both sides, we get minus 1.28 times sigma is equal to 14.21 minus mu. If we divide by minus 1.28 on both sides, we get sigma is equal to 14.21 minus mu divided by minus 1.28. We can use the similar formula for Z2 because we know X2. Again, if I move up, X2 is the value on the right, which is 17.68. So Z2, so if I write Z2 is equal to 0.84 equal to X2 and X2 minus mu by sigma. Now, X2, if you remember, X2 is 17 point something, right? 17.68. So we can write 0.84 is 17.68 minus mu divided by sigma. Or if we solve for sigma, okay, from this equation, we get, let me move up. Same as before, similar to before, we will multiply by sigma on both sides to get 0.84 times sigma is 17.68 minus mu by sigma, or sigma is equal to 17.68 minus mu divided by 0.84. So we have got two equations for sigma. Okay. So if I move this a little bit to this side, oops, sorry. You see, the first equation is this one. So this is equation 1 for sigma. This is equation 2 for sigma. So basically, we will equate those two values of sigma. That way we will get, if I move this a little bit up, oops, okay. So I should be here, move this a little bit up. So we will equate basically two equations for sigma, 14.21. Okay. So 14.21 minus mu divided by minus 1.28. Equation for sigma is equal to 17.68 minus mu by 0.84. Now we will basically multiply both sides by 0.84 in the numerator first, and then minus 1.28 in the numerator. So it will become 0.84 times 14.21 minus mu is equal to minus 1.28 times 17.68 minus mu. Okay, so we have to solve this equation for mu. Okay, so let me move this a little bit up. So this becomes, I'll distribute the 0.84. So 0.84 times 14.21 is 11.93 minus 0.84 mu. And then I'll distribute the negative 1.28. So it becomes 17.68 times negative 1.28, which is minus 22.63, and then plus 1.28 times mu. Okay, so basically I can add 0.84 mu on both sides, and I will get 11.93 is equal to minus 22.63 plus 1.28 plus 0.84, and that is equal to 2.12. Oops, sorry. Plus 2.12 mu. Then add 22.63 on both sides and move this a little bit up. So 22.63 plus 11.93 on the left-hand side is 34.56. 34.56 is equal to 2.12 mu. Oops, let me erase this. So 22.63. Okay, on both sides. So divide by 2.12 on both sides. And mu is equal to 34.56 divided by 2.12, which is 16.3. So mu is 16.3. Let's take a look at the options they have given us. Yeah, there are some options with 16.3. So let's solve for sigma now. Now we can plug in any of the equations for sigma. We can use equation 2, which states that sigma is 17.68 minus mu divided by 0.84. Okay, so substitute mu equal to 16.3 in equation 2. Equation 2 for sigma. So sigma is equal to 17.68 minus 16.3 divided by 0.84, which I can do in one step in my calculator. So I'll put the left parenthesis 17.68 minus the right parenthesis minus 16.3, then the right parenthesis divided by 0.86. And the answer is 1.60. So let me highlight my answers. Okay. Oops. No good, no good, no good. Sorry. So let me highlight the answer. This is the answer for mu 16.3 and this is the answer for sigma. So this is 16.3 and this is 1.60. Okay, so let's look at the options now. Let's move up the up and let's look at the options. So 16.3 and 1.6, the answer is B. This matches with, so I write it down, option B is the correct answer. Okay, so mu is 16.3, sigma is 1.60. Maybe I should remove this highlight. This again. 16.3 is the answer for mu, and sigma is 1.60. Okay, that is option B. If we move up, oh, I don't want that. So remove this as much as I can. Okay. So if we move up, option B, mu is 16.3 and sigma is 1.63, which matches with the answer. Option B is the correct answer. Again, to summarize what I did, we were given two x values. And the first x value gives the first one gives the x value for which the area below is 0.1. And the second x value gives a value for x area above which is 0.2. So in the second one, we can find the z-score for which the area below is 0.1, as we did here. Okay. So area below Z1 is 0.1. That came out as minus 1.28. And for the second one, the area above this Z is 0.2. So area below is 0.8. That's what we have to plug in the calculator and calculate. Basically, we will get the Z2 value and the Z1 value. Now we will set up the equation for Z, which is x minus mu by sigma. Z score is just tells us how many standard deviations you're above or below the mean. Above is z-score is positive, such as for z2. Below, such as for z1, where it is below the mean. Okay. And we solve for sigma in both cases. Then equate the value of sigma or equate the expressions for sigma and then solve for mu. Mu works out to be 16.3. And then we substitute back mu in the equation for sigma and calculate sigma, which comes out as 1.60. So the closest match to the correct answer is option B. So the trick is to use the definition of the Z, find the values of the Z for which the areas are given, then again use the definition of Z to to determine equations for or expressions for sigma. There will be two expressions for sigma, equate them, then solve for mu. Take that value of mu, plug it in any equation for sigma, and get the value of sigma. Okay, it's a long process, but this is the only way you can work this problem out. If you have any question, comment, write me a note. Please, I request you to write a note so that if you have any question, I can answer it so that I know how good I'm doing the job. If you think you do not like this video, give me a thumbs down. Otherwise, please give me a thumbs up. And if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And please do not forget to watch me tomorrow when I'll be back with another interesting problem, interesting solution. Thanks for watching. Have a nice day. Take care. See you next time.